My hair is just gonna look absolutely atrocious today, but that's okay. Hey, Kevin. How's it going?
Hey, good. How's it going, Zach?
Good. Finally got all of my headphone situation figured out.
Nice. Yeah,
That was
that's
a
good.
nightmare.
It's better than having to be on your desk. That's
That was something else, I'll tell you what.
not ideal.
Nope, not ideal at all. That's how I did it. Okay. I'm writing a very base example of a singleton class since I believe it talked about that in.
I don't remember the term singleton, but that's probably just me.
That's okay. It's a very weird thing, especially in Python. It was in chapter 7 when it talked about
Oh, okay.
pass-through
I haven't done.
variables and introducing context objects to store global states.
Gotcha. I haven't done chapter 7 yet.
Got it. I wrote notes for it in case we decided to get there in the conversation, but I wanted to have an example as well for
I see.
people to look at
Yeah.
and
I was like,
understand like
that doesn't sound familiar. And I was trying to pay pretty close attention when I was reading. So I was kind of concerned that I like missed a whole section or something. So
no, that's not at all. I think that's all I need. Right. Right, because then everything else should just be okay. Nice. So then I can. Oh, that makes sense. Hey, Stefano, welcome.
Nice to meet you.
Let's see. I'm quickly doing a demo or writing a demo, and then it's not quite working, which is not what I expected, but that's okay. Maybe we can debug it live. Hey, Vladimir, welcome.
Hey, how's it going?
Good. How are you?
Pretty good, pretty good. Nice to finally meet you, Zachary.
Yes, it's been a bit.
We've exchanged a couple of messages on Twitter, but first time I think we speak face to face.
Yeah, I think so.
Where are you, Vladimir? It looks dark there.
Yeah, it's Berlin.
Ah, Berlin, nice.
Ah, okay. Nice. Very nice.
Yeah.
We'll give everyone, I don't know, 2 more minutes to pop in, and then we can get started. Let's see. Well, I also magically debug why something that should be working in this demo I'm doing is not actually working. Oh, that's why. And there we go. Now it works. We have a singleton class design and accelerate for certain things that like will store the state, which I'm going to show at some point when we get to chapter 7. If we get there today, then I'll show it today. If not, I'll show it next week.
Oh, so you guys already went over chapter 2 and 3.
Yes, chapter 2 and 3 kind of were also last week because the chapters are so short. It's all in the recording though.
Okay, I'll have to do a bit of catch up. I was looking at chapter 2 and 3. All right, so your chapter 4 is today, right?
Yeah, it's chapter 4 and 5, possibly 6, but I'm basically going to go through my notes throughout the whole talk, and my notes are basically verbatim from the book, so you should be able to follow along fairly okay. There should be a link to the notes in the Discord over in Discuss. Let me find that for you. There you are.
Okay, cool. Thank you.
No problem. It might just be us 3 today, so we can sort of talk about whatever we want after we sort of go through these notes. So Kevin, how what'd you wind up doing for that design for the API?
I don't know. I still haven't really come up with anything I'm super excited about. I have so far what I've done is I've the side that's like processing the rules, I have just as like a list of rules so that you don't have to try to have because what I was doing before is I had the actual value on the rule processing side and then all of the rules on the other side of like the min value, max value, things like that. And it ended up being like really, really complex to just like match those two things together. So that was, I think the first thing that I did that was helpful was to say like, all right, this object is going to have all of the information that you need to process it. And then it's kind of, I don't know, it's a little bit different to actually get it processing. Like the way that it would work if I was using a pure Python implementation is like I could tie the function like I'm doing in the Discord. I would tie the function to the object itself, but because I'm using I'm using like gRPC protobufs, it makes that a little bit more complex to actually create a unique function for each different object. I think I found a way to do it, but it just added a bit of complexity. So I don't know. It's that's what I'm currently kind of going down that route though, of like each function, like each rule type is responsible for its own pass or fail. And then the side that's processing it just has to say, like, for each rule, run through and say whether or not it passes or fails.
And I mean, that does make the most sense, I think, honestly, because otherwise you'd have to deal with a giant growing class that deals with its own, that has to know everyone's rules at once.
Yeah,
Right.
that was what I had before, and it was, I mean, that's what I was refactoring from. It was a class that had been like just growing technical debt for years at this point, and it's like, I know that this isn't sustainable. Like it's not something that I'm gonna, I don't know. I knew I needed to change something, but it was like, I definitely felt like I was very far down this has been I don't know, an investment into the I don't even know. I was just getting very far down the, like, I can't add any features because if I want to, it's gonna be, I mean,
your technical debt became too big.
Right. Yeah, it's like not paying anything down at that point. So I've done a lot of refactoring, and it feels like things are going slow, but I think it's just because it's, I'm paying off a lot of that debt.
Yep. I mean, it's why some systems, as sort of Eugene talked about last week, never quite get updated and refactored and kind of just sit there in purgatory because it's a doggo. Because it's just cost too much to actually be able to rebuild the system. Like, I remember one example of that was at my old job, they were using FastAI version 1. And I was still working there when FastAI v2 was like in development, when I was going through Walk with FastAI, and like I knew the framework inside and out. And they were wanting to update this code base to use v2 instead of v1. And I was like, okay, cool. It can take me probably about 20 hours to like fully update your code base, get it most of the way there, because like I had worked with it for so long that I knew basically what to do. They couldn't afford that. And so they just lived with the technical debt of this product that just died, a year later because FastAI v1 became like just so out of scope with everything else, with deprecations. And that's sort of, another example of, it's the same framework, but like you have to keep in mind how design decisions can impact the future in that way. So it's very good that you could get ahead of that and like not be too late and refactor it all, even if it had been, what you said, months and months of this, you've been working on it. So
yeah, it's been probably about 2 months now that I've been working through this problem.
Okay, that's not too bad. All right, welcome everyone. I'll go ahead and share my screen with the notes. So we're gonna kick off basically where we left off last week, which is, I believe, chapter 4. If that's incorrect and we didn't talk about chapter 3, someone yell at me, please. But chapter 4 is where we started talking about modular design, this idea of like deep modules and shallow modules. So the way that modular design works, and this is basically like how you would imagine any Python project, right? Any file in a Python project can be considered a module in the basic understanding of it. And each module has what's called an interface. And so this is how users interact with functions in this module. So Python doesn't have this idea of like private and public in terms of, you can get almost any information out of Python files, but you can expose certain functions in the Python file directly. This is like the dunder all functionality. I can show an example here in Accelerate of us doing this, where we have, and you'll also find this in like transformers as well. So we have the init file here, right? Hopefully it's sharing that screen and you guys can see it. Perfect. And so in here, we import certain classes and certain functions from different files. And this is sort of an idea of limiting the scope, right? Nothing is ever private, but I'm exposing to the user directly certain interfaces in these files. You know, accelerator can have more than just the accelerator class, but we're saying here, this is what the user is going to know to get from the accelerate class. They can import directly if they want, but this is what we're showing them. And then we have this idea of abstractions, which basically allow you to, maybe my headphone thing will work, essentially hide unimportant details from the user. In sort of the same vein of limiting the scope when you import a module, you keep high level behaviors. So in trainer, for instance, from transformers, this would be like, you know, trainer.train exists. You don't have to know that, like, how it gets the training data loader from your data set. That's an abstraction that a user doesn't need. They just need to call train.train after passing certain things. And then we talk about deep modules and shallow modules. So deep modules are powerful functionality with simplistic interfaces. The trainer is, again, a very good example of this, where we have a lot of complexity in a class. I think that file alone is like maybe a couple thousand lines at this point. But the functionality in that class is very strict and simplistic for the user in terms of what they can do and what they should do in a typical workflow. And so you can hide all that complexity behind these specific functions that the user wants to see and knows to use through the documentation and whatnot. And then we have shallow modules, which basically would be like saying I have a trainer class, and then I have like an image to image trainer class, and then I have a seek to seek trainer class, and I have all these shallow classes that change like maybe one line or one slight function in the base trainer class. And these are what we call shallow modules. And they actually add complexity more than simplifying it, because you're creating 1.5 million different classes that all do the same thing, bar one tiny tweak. And it's a sign of shallow modules in general are kind of bad in a sense, because you're not adding extreme value versus what you're building into it and trying to solve. And so then it talks about effective complexity, which is basically saying, okay, if we continue with the trainer, I understand that for users, the simplest way I can build this is just having a user create a trainer and call trainer.train, and that's it. And it'll do all the magic for them in training a model, reporting results, everything.
I think of this as like something that Fast AI does really well, is like choosing solid defaults for the most common use case, or like the intended initial use case, I guess. That's what I thought when I was reading through that part.
It doesn't. In some ways, the idea behind it is good. The implementation of it is where it fails, because it uses a lot of Python magic that adds a lot of complexity through 1 million different ways. For instance, you have, so like, let's take, for instance, Actually, here, we can talk about intuitive interfaces now. So like classitis is when you have a million classes, right? So that's the idea of different trainers for slightly different things. And then intuitive interfaces described in plain language are often more intuitive and understandable. So for FastAI's case, with its learner, it has a few different ways for you to train models. You have like fine tune as a function, fit as a function, fit one cycle as a function, and it has all these fit functions that a user can pick from. But understanding what each one does, when it should be used, and how it should be used is a very common question that comes up in FastAI that people don't understand. If I were to rewrite it myself, I wouldn't do that at all. I would have one fit function, takes in a string or an enum that picks your scheduler. One function simplifies it all. They just have to know that I need to call this, and I can look at what these different options are.
And it would choose one of the probably fine-tuned by default or something.
Yep.
Like if you didn't select.
Yeah.
Yeah, because that's fair too. On the it isn't side of that argument.
Yeah, because FastAI does do very well at picking good defaults. That is one thing that the book talks about, I think, in a later chapter, where if I don't have it in my notes as this is a good example, it will be in there. It has very, very good defaults for what you're doing and how the user should be performing certain actions very well. So it is a balance at the end of the day, and part of it is just how the framework was written. Were there any questions, observations, anything you want me to go a little more into with this stuff in chapter 5? Examples? Anything like that, or what's up, Vlad?
Yeah, thank you. I'm wondering about how do you balance the trade-offs between simplicity and also allowing extended functionality for, let's say, super users? Is it just parameters? Is it programming hooks so they can extend it? What's the best kind of approach in your experience?
So
simplicity and extendability.
To one extent, I would say hackability is a big factor. So it needs to be quick enough that a user can go in, understand everything that's happening in the code. And if they want to like create a custom class for it out of it that's inheriting it, doing something like the custom trainer class where we change one function, that's fine. The user can go do that and overload it if they want. That's one option. Typically, another way I've seen with training classes in general is most frameworks now introduce this idea of a callback. So you allow injections during certain events for custom code to be ran, which makes sure that the base class can be very simplistic. It's just a caller essentially that says, okay, call this event at this time. And then you can attach these hooks in for the user that they can go write themselves to do XYZ problem. That's the main way I've seen. Otherwise, if you keep a code base clean and very easy for a user to follow, hackability is rewarded in that alone. Because if a code base is very clean, easy to use, doesn't have weird namings, keeps to what we would call the standard practices, which isn't a standard, but if everyone else benefits from it, then you shouldn't not do it. That in itself gives you a certain level of hackability. Like, another good sign that your library is very hackable is if users are putting in PRs. Right? If we're assuming from an open source perspective, if users are making pull requests and changing custom code and trying to improve the framework of whatever you're doing, that shows that you have a very good implementation of whatever you're making. That is very easy for users to go and attach their custom code to it. For instance, with Accelerate, we almost don't have to do the implementations for new for like if a new
Pluggable functionality or something like that. Yeah.
like new logging function or even a new hardware. Like let's say Google came out with like TPU v5. The Google team pretty much makes the PR for us because Accelerate's very easy to change that. The loggers are another great example where because of how the API is designed, I think just last week we had a PR in that honestly was one of the best PRs I've ever seen in Accelerate, where it added a new tracker, right? A new training tracker for Accelerate. And they were just able to write the entire thing following this general tracker class, which is an abstract class. So we do use ABC and Accelerate a little bit. And, I went through, looked at this PR, and it was actually perfect. There was nothing wrong with it at all. And this was just a random user that went through, wrote some tests, looking at the rest of them, wrote the tracker following the rest of them using the exact same paradigm that the rest of them were written. And the only thing to add in my PR review was, can we make sure we add this in the test settings? So that way your tests can be run. That was it. This PR was beautiful, golden. And with most of these tracker APIs, that's usually what we wind up happening. So if you can make something where the implementation is obvious for them to build around, that's a really good sign.
Excellent. Thank you.
No problem. Any more questions or comments?
I think the only other thing I struggle with is, so I think the classitis side of things makes sense of like getting kind of, I don't know, going overkill with the number of classes inside of a module. Like this is, even though you're breaking out the functionality, you're basically going overboard on that side of things. I think it's hard. One thing I struggle with is how far to pull back from that. It's like when do you, like, I guess what level does it actually make sense to split things up? And I think it's easy to go overboard on the other side too, of just like putting everything in a single class or function in a module. And I think that's probably too far as well.
So there's a quote in chapter 7. For a design element to provide a net gain, it must eliminate some complexity that will be present otherwise. And I have my own twist on this as well. And it must also not add further complexity that outweighs the original design. So I can have a class that does 4 different things, which in of itself is bad. Classes should mainly be around one thing. But if splitting that up into 4 different classes that I then have 4 different inheritances for adds more complexity for the user and myself, say they're not being reused, it's just in this one class, then keep it. That is not a net gain. That is only adding complexity and magic and confusing code. But if splitting it up allows me to then reuse it, across 16 different classes, each tweaking and simplifying their interfaces because they have a pick and choose of what to implement and what to inherit, then it's worth it.
So in that case, it would be like, if for the first time through, just write the function without trying to like aggregate some function up to the top because it might be used later. But then the second time that you're trying to do something similar, like same functionality in a different module, then like combine that functionality into a, I don't know, not a parent, but like a utility type module that both of them would call.
2 is not enough where I would do that. because now we're getting into dry, right? Don't repeat yourself. One thing I've noticed in transformers and accelerate and everything sort of Hugging Face does, aside from like model implementations, because that's a lot of copy and code. If we're talking about the base framework, I've generally seen about the 3 to 5 mark is where that point hits. Because the other question to think about is it clear for the user reading the code for me to keep this 2 to 3 lines that I'm extracting out? Or does it make it harder to read the code? I can answer this for you if I go pull up any fast core code from FastAI, because FastAI follows that, where if it's any code that is repeated twice, it gets abstracted into a function. What winds up happening is you have functions that call 16 different functions, where each of those functions are then nested with other functions that call them. And so you have this never-ending chain because you don't want to repeat yourself and you're abstracting this duplicate functionality. So I generally follow like if it's 3 to 4 times, or I know that it's something that maybe a user would want to call as well, like as a utility, then I'll go ahead and abstract it and shove it into a function.
So do you ever do that? I mean, even if it's like a single line of code that's just like a ugly line of code, do you ever abstract that into a function just to be like, yes, it looks ugly, but all this is doing is, updating the weights or something?
Yeah, like, here, check whether something's compiled with torch compile.
Yeah, it's like you don't have to know what this actually does. It's just like, is it a compiled module? Okay.
Exactly. And it's, some ugly torch version checks and in his instance. If we were careful about this, I could write that without an if else, and really it could just even be a one-liner. But it made sense to abstract it out because a user might want to call that. Mm-hmm. Right? A user might want to know if their code is compiled, or anything that implements or integrates with the framework would want to do that. There should be a few others in here, I want to say. Yeah, like, is a port in use, which in actuality,
and in those cases, it makes sense because you're reducing the complexity of the code by pushing that into a function that's probably not going to need to be updated, or if it does need to be updated, only that piece can be updated then, of like, oh, the way that we check if a port's in use has changed. Like, we can just change what's in here and not have to worry about it in a bigger function then.
Exactly. It also reduces cognitive load on top of that, because like, let's keep looking at, is port in use, right? If I saw this in code, I would have no idea really what's going on unless they put a comment in. Seeing is port in use and passing a port number is a lot easier for me to understand as a user what's happening in the background. So on top of like, sure, we're reusing these same 2 lines of code and they only have to be updated in where is port in use called, if we change a parameter or something. But it also acts as simplifying our code by adding an interface for the user to read and understand. Does that make sense?
Yeah. Yep. That makes sense to me.
Perfect. Very good question. So if we go back, so we finished kind of with chapter 4. So now we have chapter 5. And chapter 5 is all about this idea of what do you want to show the user? And, as I said before, Python doesn't really have the idea of private, right? Underscores are different in Python versus Java, because Java, if you start anything with an underscore, it is automatically determined as private, and then it is impossible for a user to get access to it. In Python, you have underscores attributes that will show up. And you can technically make it fully private by hacking a double underscore. And it's got a weird, complex way for a user to go find and use it. But information hiding in Python is still really good because while users can get to it, generally we're taught underscores mean private. And so this chapter, I think, is still really important when designing your APIs and designing systems, even in Python, because even though the rules might not be set in stone, they're malleable. How you present your interfaces to your users still matters because it's still going to be the first things that show up when they try and investigate the class. And so what it basically describes here is when you're encapsulating certain information for a class, for a module, and doing so simplifies much of what's going on. So this is sort of in the same vein chapter 4 talked about when I mentioned like how the trainer simplifies doing everything else with .train, sort of this idea of information hiding as well, because the users don't need to know about that. And doing so basically lets you come up with simpler interfaces, right? Users don't need to know 1.5 million different functions, 1.5 million different functionalities. They just need to know what you're doing. So the docs can be simpler. Your cognitive load of the user as they're learning your framework is simpler. And this has to happen by minimalizing exposure to hidden details, I would say. It mentions 2 different levels. The first one is absolute concealment, making it fully invisible to a user. And so what this would mean is, so if we go, I can actually bring up the trainer's code in full here. I think it's a good example. I keep bringing it up without actually showing what it's doing. So if we go to the trainer here, right, you're going to notice it has a whole bunch of arguments. And then if we look at some of the functions here, right, we have some where a user might want to call things where it makes sense for a user to look at them. Like we have add callbacks if a user wants to add a callback that happens during training. We have remove callback. But then we also have things like move model to device, set signature columns, where a user doesn't really need to know what these are doing. They're still exposed, of course, but again, it's this understanding of a user's not going to do that. And so from me just looking at this code, I know, okay, I can add callbacks, pop callbacks. I can get the training data loader if I want, the eval data loader, the test data loader. I can create optimizers and create schedulers if I want. These are certain things that I know I can access and work with versus having to know, oh, how does eval data loader get the sampler for the training data loader? What sampler does it use? I don't need to know that information, but it's easy enough for me to come up here and see that if I want to. And it's written in such a way that lets me see very clearly, okay, it's either going to be this one, or using the default. And so it's a very easy enough interface for me to follow that scales fairly well to the point where, it's a single class that has almost 4,000 lines at this point. But users can still very quickly understand some of what's happening under the hood. It's not overly abstracted out. Another example of simplifying the cognitive load is another argument in the trainer is they have this idea of training arguments. which is a very, very extensive data class, but it acts as an overly simplified interface. So that way you don't have to keep adding a million arguments to the trainer. Like say, I want, I have XYZ number of data loaders that I want to be built. I have to pass, a large array of batch sizes to be used to this weird argument. Instead, I just make a data class with all of my arguments that are possible for the user to know about, that they should. And then they just have to make this single class. And this has future proofing as well, because now we're updating a data class. The signature never changes. The implementation under the hood does, but we can support backwards compatibility, because all of a sudden now it's not going to show, oh, we got this weird parameter that doesn't exist in XYZ version of the framework. Why doesn't this work anymore? It's now abstracted to the training arguments. And it's also now our single point of truth. So if there's anything we need to tweak, anything we need to test or modify, we just have to create a training arguments class and specify what we want to do. Let's see. So leakage. So information leakage happens whenever a decision is made in multiple modules, creating dependencies between them. The general idea of leakage is when you're, there's a few different ideas when I tend to think of as data leakage. So the first is when, we had this idea of shallow modules where we had different trainer classes that all tweak one different function or one different line. The first one would be if we're too far in and we're noticing like 6 different classes that are all the same girth as the trainer class that tweak these few things. That's the first idea, and each one depends on the other as well. So like we could have a trainer state and then like a trainer class, and tweaking between the two of them is so interlocked that we can't actually work on just the trainer class. It requires us to then also work on the trainer state. I think would be a better idea to think about it. The idea behind that is modules in general should be self-sufficient and independent. You can make helpers for modules to interact between two different ones, but one should not have to wholly depend on the other for it to work. There are exceptions in this when it makes sense. Like in Accelerate, we have the accelerator in one and the accelerate state in another. And the accelerate state helps dictate a lot of functionality in the accelerator because it contains a lot of information that persists. But at the same time, changing the accelerator doesn't force us to change the accelerator state. Changing accelerator state could make us change things in accelerator, but it's not a two-way street. It's only a one-way street. So it's not as bad. And so it's more of a yellow flag of be aware that like because it didn't make sense to have it be inheritance, right? Because inheritance would be great because we can then just rely solely on the module itself. That doesn't make sense. It's a stateful object. I'm going to show a demo of it in a bit. But it's more of a yellow flag, and so the leakage isn't quite there, and it's okay. To mitigate this, it generally talks about reorganizing your classes. So take a look back at the full implementations. Check to make sure that, okay, so we have like class A, class B, class C, and then we have class D that relies on all 3 of them, and it's the only one that does it. Should we just make class D implement all of A, B, and C then? If it's not used anywhere else and its functionality is only for that, maybe that's what we should do. With the caveat of sort of this quote that I mentioned back in chapter 7 again, if the new implementation doesn't simplify everything and make it easy to maintain, then everything else is off the table, and we should keep those three classes separate. It's all cost at the end of the day, and most of the time we think of it as technical debt. I also think of it as design debt, where okay, designing this object or this class or this interface for an hour today, does that save me design debt later on when I'm having to think about how to integrate it with everything else? Not necessarily technical debt, because technical debt would be the idea of having to rewrite everything later to potentially work with it or deal with bugs. More so, rewriting it is fine. Once I have a design, I can work with it. How hard is it to actually make that design to work with everything else? So then it talks about temporal decomposition. And basically, this is understanding the actual time execution of certain objects and certain codes, and whether or not, because of how certain setups are done, if that can lead to information leakage on top of it. The example they had there was using 3 different classes to read, write, and then modify a file, when it made more sense for that all to just be handled independently. And then it discussed class design and information hiding, which a common mistake is to have one class that could be in 10 different shallow classes. So Eugene, your example last week, I think, would be a very good example of this, where something that should be a very simple implementation, if we all just inherited one deep module, instead has to be split across 10 different ones that all don't really add anything. And then a different idea it mentions to help it is just increase the size of the class, increase the number of functions, increase the attributes that it's keeping track of, and think about giving one central class a bit more information for everyone else to benefit from. And then we get into defaults. So, as Kevin mentioned earlier, FastAI did really good with good defaults that should be designed for the most common case. And as a result, it sort of ties back into information hiding, because if you have good defaults, a user never needs to change them. And a user never has to look up what they do. And so you kind of have information hiding because they don't have to tweak it. They understand these are the defaults. That's what you need to do. And they don't have to go and look up anything unless they want to become a power user. The other side of that is when you have too many features that can lead to cognitive load. So on the flip side of that, let me show. If I were to rewrite FastAI's learner, I would very much so make it use the I would probably make it use a data class to handle everything, because its init function is starting to get very bloated. And then when you deal with other classes and implementations on top of it, it can get even more. Because, for instance, like weight decay, batch norm bias, train batch norm, momentum, these are things that in the half decade I used FastAI, I never touched, really, nor needed to. And so I wouldn't expose them. I would expose them in a config of some form, like a weight decay config. But having more and more attributes like that can largely increase the cognitive load, especially if it's not documented well. And I hear the next question, possibly in my head at least, of, well, how does a data class simplify that? because now a data class, you can just shove all that somewhere, and it's increasing the cognitive load because now they have 1.5 million different parameters for them to read about. But I think the difference there is how you organize the data class. Because if you write the most commonly used parts at the top and then the least commonly used later in the data class, you can still have that information hiding because a user will be lazy. And if you just keep what they need towards the top, they're never going to read the rest of it. And so it helps with that in a bit versus having an insanely long parameter string instead in some general interface that has more than what they commonly would need to use. And then it mentions some good guidelines. So reduce the number of places where a variable is used in a class. That will eliminate dependencies and reduce complexity. And it only makes sense if that information that you're trying to hide isn't needed outside of its own module. So if module A is tied to module B, right? If we take the accelerate state example, let's say accelerator needs to use the A attribute of the accelerator state. I shouldn't make A private. I should expose that for the user to know this is what we're tying it to. In accelerator, how we tend to do that is we would make accelerator have an A property. So that way the information is tied, users can see very quickly, this came from the accelerator state and it's A attribute and it's tied very cleanly. But there's other aspects of the accelerator state that users don't need to know about that we don't pass through because it's for our own internal structure. And then it mentions a paper in there on criteria to be used in decomposition systems into modules. At some point, I might read that. I have other books that I want to read that are more interesting than reading a paper on decomposition. Personally, that is not one of my favorite ideas of programming, if I got to be honest, but it's good to know. So that was all of chapter 5, which was a chunk. So is there any questions on encapsulation, information hiding, or class design from anything I said there? Any pushback? Any comments?
One of the things that I would like to clarify is it seems that it's okay if we introduce several dependencies in forms of classes. Let's say, let's go back to the trainer class. And at some point, let's say trainer class takes the trainer state, takes the trainer context, I don't know, a couple of others, as long as the communication is not two-way between these classes and modules, right?
Yeah. And the other idea with that is, and how the trainer does this and how Accelerate does this as well, they don't inherit. They just store the object. They store the state as an attribute instead. So you're not tied to it still. It's tied to it in the sense of it's an attribute in the trainer and you can use it, but you are not handcuffed to its implementation. The trainer can still have its own implementation as an interface for whatever we're trying to do with this stateful class. And so at the end of the day, you're still always limiting how much inheritance.
It does kind of handcuff your the config side too, of like removing configuration options, right? Like, because you're depending on that config being available from the config class. Like if you start using it in your accelerate module, and then are like, oh, this is super old concept, nobody uses this anymore, let's delete that from the config options list. You potentially, like, there is some I don't know if that's a dependency, but like you have to be mindful of where it's being used still in that case, which is not ideal. Is that true?
So the answer to that is actual true software engineering deprecation cycles. So you announce, like, if it's a very big change from the ground up, then you say until the next major version number, you raise a warning. Accelerate has a few of these where, like, it was there from the very beginning. No one really uses it, but because some people do, we're always going to raise a warning that once 1.0 gets released, this is being axed and things will break.
Is there any are there any Python libraries that actually handle that deprecation cycle for you of like read the version number and throw a warning up until that point? Okay.
No, that's up to
Just
you
have to
to
kind of
create it.
manually do that.
There is a specific warning called a deprecation warning. So that is up to you. I can show a few in Accelerate. Let me see if I can find a few.
Yeah, I've seen deprecation warnings. I was just curious if there were any Python libraries that would, like, you know, add the deprecation warning, and you could say once it gets to this version, then start, like, throw the error.
No, I think Transformers does yeah, so like we have warnings here that we tend to use. I think the trainer or Transformers uses a few different decorators that can tell. But generally, not that I've seen or used, because I'm also not sure that's something that should be automated. Because if you automate it, how's it going to know every single case it's going to be used? How's it going to know between libraries if it's going to be used? You know, very basic example of this is like, because of the integration now, Accelerate and Transformers are highly integrated because the trainer uses Accelerate. And so if something breaks on the Accelerate side, and while we might have had a ton of warning for it, and we can automatically change everything in Accelerate, we can't do that for Transformers. And so you risk breaking later modules by just leaving it to a decorator that doesn't actually say anything per se, but knows to change the code later on. That's something where human in the loop would probably be the best case scenario. Despite it adding, you know, another hour or two of work as you go through and write all these warnings. Eugene, you had a comment, I think?
No, I didn't.
Okay, all good.
Yeah, all good.
Anything else before we move on to chapter 6? Perfect. Actually, I might run out of time before chapter 6.
Yeah, we only have seven minutes.
All right, so, well, next week, since we're starting to get into very nitty-gritty things, let's do...
Chapter 5 was heavy. That's a lot of information.
It's only going to get heavier.
Oh, man. All right.
So next week, we'll do chapter 6 and 7. Chapter 6 talks about complexity and specialization classes. And sort of tying back to this, writing, you know, 6 different classes to do very specific things. When is that good versus when is that bad? And then chapter 7 talks about layered system abstractions. For the FastAI people, we're going to have fun with that because I'm going to talk about the layered data API and its faults. Because it's 2 layers, technically 3, some would even say 4. And that adds a lot of complexity to something that should be a free, easy to use interface. And it's because of 1 or 2 things that's talked about in this book. So let's go ahead with that, I think, and we can end the call there unless there's any other questions.
I wanted to ask. Oh, sorry, Vladimir, you are muted.
To me?
Yeah.
Yeah, sorry, Eugene, you go first.
Oh, yeah, I wanted to ask, for folks that actually, for more of their work, so in some context, my work, I don't build that many frameworks. So maybe I might build a framework here for a bandit or for factual inconsistency that other people can use. But the bulk of the work that I do and the bulk of the work that I advise teams on, it's really data pipelines and machine learning pipelines. So for that work, I find certain things like, information hiding. I actually want to show as much of the information as I can when I'm building pipelines so that people can easily tweak, building how they generate the features. I actually wonder, for work like that, where you're building pipelines, where it really needs its nitty-gritty down to the business logic, where it's not really reusable, what's your advice on how we would apply some of these? I think some of the benefits are still there, such as being strategic, trying to make your chapter 3, trying to make your pipelines as broadly applicable as possible, and the nature of complexity is just modular design. But some of the rest, I wonder if you think it would be completely appropriate, or is it that's just not what this book is written for.
I think where the book talks about later, and if not the book, then it's my own idea. But I'm going to fully say someone else came up with it first, is where simplicity in the code base and simplicity in the interface cannot be done should be balanced by the level and quality of documentation. Because if you can't simplify it, then you need to make sure the user can fully understand it through as many guides as you can at various levels as you can, and things that are very easy for them to follow that don't get them into a never-ending loop of going further and further down the tree. You keep it at certain levels and then let them grow and follow each more and more as they want to sort of customize more and more features, I think is what I would say on that.
I think that's exactly right. I think you answered my question indirectly. I think the question is there going to be a user? For most of these pipelines, there's no user. There's just subscribers to the end state of your data. And they don't really care about updating your pipelines. For example, for a machine learning system, you're building a recommendation system. The user is the consumer where the recommendations are being served. No one's going to tweak it except developers themselves. Now, that's different if I'm building a framework, an evaluation framework that I try to guide people along certain best practices where there's going to be users. That's where the philosophy in this book will be very relevant. I think that's a great way of thinking. Thank you, Zach.
No problem.
Zach, I was just going to make a small comment that, you're already doing this. It would be great if we could add more of these examples as we go through the points in the notes. I think that it will help us understand and remember these principles much better.
Yeah, that's something I wanted to try and get done this week for chapter 4 and 5 that I didn't quite get to, because the book talks about a lot of examples in Java.
Yeah.
It does not talk about examples in Python. So if I can get some time this week, I'm going to do that. If other people have some time and want to do that, the code base GitHub is there. Feel free to shove a PR in with the week and chapter and what it's doing. Because yes, I think it'd be very good for us to have sort of a code base of everything being used here. There's another code base I know of that talks about different Python paradigms in terms of design that I tend to go back to every once in a while to just look at a different idea. I'll link to that in the Discord as well, because it talks about different things like stateful classes and what that can look like in different interfaces in Python and its pros and cons, and it's cost affiliated. So I'll link to that in the Discord for us to look at as well.
Is it this one?
It is not Effective Python, but that is a great book.
That is really good.
That is a phenomenal book.
Yeah.
I actually wonder if it would also make sense that every now and then to just take a sample of code and critique it based on what we've learned here. I would be happy to volunteer my open code on GitHub. I mean, I shared with Zach 2 examples last week. One was a machine learning framework, simple decision trees. Another one was a data pipeline. And try as hard as I could, that I couldn't find a way to simplify that data pipeline because it's so specific to the data that it's pointless. No one will be able to reuse it.
Yeah, let's go ahead and if you have code that you want to just shove into open review. Let me think if I have a good channel dedicated to that. We could probably shove it in book questions and repurpose that since no one quite has questions on the book here. So I'll just rename this into code review or roast, just to make it a bit more fun.
I wonder
mhm.
I wonder if the I don't know, the data pipelines, Eugene, that you're talking about, if there are concepts that can still be generalized of like these things, like these pieces could be maybe pulled a layer up to, you know, speed up the development
Let's do
process as
that.
well.
I'll add those two. I'll add the code for those two into that channel. The thing about the data pipeline is a very specific JSON file from a very specific website. That's why there's no way it's going to be reused. I think the business logic was never be reused. The things about how to create the graphs and the edges, maybe they can be reused. I don't know, but we can try to roast it.
Yeah. I think chapter 6 is a good, probably a good one for that as well. Talks about, you know, specialized code and where that should go.
Yeah, chapter 6 would be really, really good for that, along with chapter 7, because another part of chapter 7 I didn't really mention. It's going to talk about implement interface duplication. There's a whole part of it on interface duplication. So both of those would be really good for us to just look at this and be able to sort of think back on, okay, well, based on what we learned, how does that relate to everything and how can we write that better? So nice ideas. All right, it is 12. I'll see everyone next week, and I'll post this on the YouTube here in the next few hours.
See you next
Thanks
week.
a lot, guys.
Yeah, thanks for coming.
Cheers.
See you.
Bye.